Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So as I told you, now we are going to start the organic chemistry series. Okay, the video will be, there will be 7 parts. In the first and second part, we have already done the basic introduction and nomenclature, right? And today we are going to study about isomerism. So I'll be taking 2 videos on isomerism. So in today's class, we are going to discuss the structural isomerism and geometrical isomerism. And in the next class, we will discuss optical isomerism. Okay, so students, you have to sit with a notebook and pen and write down all the examples, all the points, important formulas and everything, so that you can understand the basics of organic chemistry, right? Many of you complain that in PU2 you do not understand organic chemistry. It seems very tough. That is because your fundamentals in PU1 is not clear, right? So that is why this series is very important. Please watch all the videos. Do not miss any class in this series. Okay, so let's get started here. So as I told you, we'll be discussing, so part 3 today we are discussing isomerism I'll be covering, and in part 4, that is in tomorrow's class also, we are going to do optical isomerism in detail. Okay, next class we'll do reaction mechanism, then purification and qualitative analysis, and then we'll be studying about quantitative analysis. Okay, fine. Now coming to year-wise weightage, as I told you directly, this chapter do not have much weightage, but yes, the fundamentals of this chapter are very important to understand the concepts of PU2. So this chapter should not be neglected at any cost. Okay, fine. Now I want to introduce you to the PU2 success blueprint test series. So to help you to get 95% and above in your PU2 examinations, Diksha has come up with this test series, which includes 12 tests, and in that there are 4 part tests and 8 full length papers, right? And the first test has already been released on 15th December, and you could have seen it would have really benefited you. Those who have purchased, they might have known that, right? And you will be also getting solution PDF, one-shot solution videos, one-shot revision videos, and doubt clarification classes. Okay, and all these can be availed at a discounted price of 599 rupees only. And do not delay this, students. This is something very important to boost your preparation. So if you want to buy, please check the link, the registration link, the purchasing link is there in the description section. Go there and buy the test series as soon as possible. Okay, fine. Now this was the homework question that I gave you from nomenclature. So first let us solve those questions and tell me whether if you have done these questions, then please do not forget to comment down the answers here with me. Okay, so the first one, this is benzene, and here there is a what we can say substituent, right? The substituent name should come first and then the parent name. Here the substituent is having 3 carbons, so it is propyl, right? So I can write propyl benzene. Okay, next coming to here, we can see a functional group, nitrile group. Okay, now if you number from the functional group, should get the least number, so 1 2 3 and 4. Okay, so 1 2 3, if I go, this will not be the longest carbon chain, this one will be the longest carbon chain. Now on the second carbon I have methyl group, right? So I can write 2-methyl, substituent name is 2-methyl. Okay, then what is the parent chain name? Because there are 4 carbons, so it is butane. Okay, and the functional group name is nitrile. Clear? Next, coming to this one, 1 2 3 4 5 6 and 7, right? So you have, if you number in this way, we get substituents at 2nd and 5th position, but if we number from other side, we'll get 1 2 3 4 5 6, so 3rd and 6th, so you'll get at 2 and 5 or at 3 and 6, right? So always add this. If you add 2 and 5, you'll get 7, and if you add this 3 and 6, you will get 9. So you should take care that the sum of the substituents should be the smallest number. So that is why this is the correct numbering. Now substituent is present at 2nd carbon and 5th carbon, right? And both the substituents are methyl group, so we have to use the word di here, right? So I can write 2,5-dimethyl. Okay, then parent name is, what root will be hept? This is a simple alkane, so heptane. Okay, next coming to the option question number D. Okay, question number D, if you see, we have 1 2 3. On the 3rd carbon we have 2 substituents, 4 5 6 7. Okay, so if I number it, 1 2 3 4, 5, 6 and 7. So on the third carbon we have chlorine group and bromine group, right? So now you should remember the substituents should be named alphabetical order. So we will get 3 bromo, okay, then 3 chloro, 3 bromo, 3 chloro, then again we have hept, and the word root is hept and the suffix is ane, okay, and the prefix is your 3 bromo 3 chloro, okay. Now coming to this one, we have 1, 2, 3, okay, so let us number that. We have 1, 2 and 3, okay. So on the third group we have chlorine, clear. So now if I use this one, you know this one is the main functional group, priority order, this is an aldehyde group, and this is a substituent now which is attached to the third carbon. So what I'll write, 3 chloro, okay. Now then the word root, we have 3 carbons, so it is propan, right, and then aldehyde group is there, so the suffix will be propanal, okay. Next we have this one, group is like this, you have CH, Cl, Cl, CH2, OH, right. So now if you see 1, 2, on the second carbon we have 2 chlorine groups, right, and on the first carbon we have OH. This is the main functional group, so the suffix should end with OH, means OL. For alcohol group we use the suffix OL, and on the second carbon I have 2 chlorine, so I can write like this, 2,2 dichloro, okay, 2,2 dichloro ethane 1 OL, okay, fine. This was the homework question. Now let us understand the isomerism. So isomerism, first we will discuss introduction and its types, then we will discuss structural isomerism, then we will discuss stereoisomerism. Only in today's video we will just discuss geometrical isomerism, okay. Optical isomerism we will discuss later in the next class, okay. So if you see what is isomerism, basic thing, okay, introduction. So isomerism means anything which has same molecular formula but different connectivity or bonding pattern, okay, or different 3D arrangement is known as isomers, okay. They can have either different bonding pattern but or different spatial arrangement, okay, but the main thing is the formula, the molecular formula should be same, okay. So now you can see, like I'll give you a simple example. Suppose you have butane, this is a structure of butane, right, and I can draw another structure like this. So what is the molecular formula here, C4H12, right, sorry, C4H10, right. One second, I'll draw here, okay. So we have C4H10, this is one structure like this, CH3, CH2, CH2, CH3, and I can draw another structure like this, CH3, CH3, CH, CH2, CH3, okay, sorry, there are 5 carbons in this, yeah, I'll make this one CH3, right. Now you see both of them have the molecular formula of C4H10, right, but the bonding pattern is different. Here all the 4 carbons are in one chain, but here 3 carbons are in one chain and 1 carbon is in branching position, right. So that means what, these are your these are called as isomers, okay. Now let us understand the types. So first type is structural isomerism. So structural isomerism should have different, okay, bonding patterns, okay. Now you may get confused with different bonding patterns. Another simple way I can tell is different, okay, the 2 isomers should have different IUPAC name, okay. If two isomers have different IUPAC name, then we will call it structural isomers, okay. Their molecular formula should be same, that is first of all very important. Molecular formula should be same, different bonding pattern, or you can say different IUPAC name, then we will call it structural isomerism. And another type of stereoisomerism. In stereoisomerism what you have, you have molecular formula is definitely same, but you have same IUPAC name also. The IUPAC name is also same. Okay, then we call it stereoisomerism. Okay, now structural isomerism are of type chain isomerism, position isomerism, metamerism and functional isomerism. Okay, we'll discuss each of them in detail. Stereoisomerism, we have geometrical isomerism and optical isomerism. So remember, if different isomers are there, different IUPAC names are there, then it is structural isomerism. If it is same IUPAC name, then it is stereoisomerism. Okay. Okay, now let us discuss chain isomerism. Chain isomerism means it should have different parent chain, then the parent chain should be different. For example, I gave you C4H10, right? Now I can draw a structure like this with 4 carbons like this, okay, or I can draw a structure like this. Right, so you can see here there are what? There are 2 isomers and they have different parent chain. If you number them or if you write their name, this will be butane, this will be simple butane, okay, and this will be 2-methyl propane. Clear? 2-methyl propane. So you see the parent chain here is of 4 carbon. Right, but here the longest chain is of 3 carbon, right? When the different parent chain is there, we call it chain isomers. Okay, now let us see the example of different position isomerism. Okay, so that means different position of functional groups, alkyl or double or triple bond. For example, we have this like for example I have CH3, okay, CH2, CH2OH. Okay, so what is this molecular formula? It is C3 3 4 5 6 7 8 O, right? C3H8O. This is one structure I did. Another structure with the same formula I can do is like this, right? C3 6 3 plus 3 6 7 8 and O, right? C3H8O. So you can see the name here. This will be propane 1OL, right? Propane 1OL, and this one will be propane 2OL. So you see the functional group position is different here, right? Propane 2OL. The position of OH group are different. It is attached to the second carbon here and it is attached to the first carbon here, right? So that is why this is position isomerism. Next, coming to, okay, now we will be telling whether this is a position isomerism or chain isomerism. We'll discuss. We have discussed 2 types of isomerism. We'll do some questions from them. Okay, okay, let us see the first one. So if you see here 1, 2, 3, 4 and 5. So this is on the third carbon we have OH group, and 1, 2, 3, 4 and 5, and on the second carbon I have OH group. So you can see that there are OH group present at 2 different positions. On the first it is present on the third carbon, and on the second question it is present on the second carbon. So definitely these are what? These are no doubt these are position isomers. Okay, clear? Now let us do this one. This is very important example. Okay, this is very important example. Now what is this? What is like speciality about that? So this is an aldehyde group. Okay, so you should always remember, if there is an aldehyde group, okay, and there is no other functional group, then aldehyde group carbon should be given number 1. Okay, the carbon numbering should start from there only. So if I see here, this is, I cannot number like this 1, 2, 3, 4 and 5. This is wrong numbering here. When aldehyde group is there and this is the major functional group, the first carbon should be of the aldehyde group. So I'll get 1, 2, 3 and 4, and on the second carbon there is a substituent attached. Okay, now here if I do, it is 1, 2, 3, 4 and 5, and on the second carbon the substituent is attached, right? Now you see this carbon or this compound has a parent chain of 4 carbons, and this question or this compound has a parent chain of 5 carbons, right? So if the number of carbons in the parent chain is different, then it will be called as chain isomers. Clear? Chain isomer. Okay, clear? It should not be, see, you might have seen that 1, 2, 3, 4, 5, then you may think it is in the third carbon, it is in the second carbon, as this example. But always remember, aldehyde group, acid group, is these groups are present, then those carbon has to be given number 1. Okay, that is why you have to start the numbering from those carbon. Clear? Next, 2 chlorobutane and 1 chlorobutane. You can see this one very from the name, the butane parent. So if the parent name is same, that means the same number of carbons are there in the parent chain, so that will not be a chain isomerism, because there is 4 carbon, there is 4 carbon. Here on the first carbon it is present, here on the second carbon it is present, so definitely it is what? It is position isomerism. Position isomers. Okay, next you have N-propyl alcohol and isopropyl alcohol. So here what makes the question tough? To know the structure, right? N-propyl alcohol means straight. You have CH3, CH2, CH2, OH. Isopropyl alcohol structure is like this. Okay. So you can see again this one, OH is present on the first carbon, OH is present on the second carbon, right? So that one will be again a position isomers. Okay, clear? Fine. Now let us do some more question. Okay, so here if you see we have 1, 2, 3, 4, 5 carbons in one chain. Okay, and here we have 1, 2, 3, 4. Okay, this question is wrong. Let me erase this one second. Just a minute, students. Yeah. Okay, so this question is like this. So you can see here 5 carbon chains are there, here 4 carbon chains are there, right? So that means this one will be what? Chain isomerism. Why? Because the number of carbons in the parent chain is different. Now coming to this one, here you can see this is 1, 2, 3, 4, 5. Here, okay, here also you should see if carbon nitrile is there, that carbon should be given first number, right? So 1, 2, 3, 4 and 5 carbon chain, and here if you see 1, 2, 3 and 4 carbon chain, right? So that means this is also chain isomers. Okay. Next, if you have this one, you have what? 2 carbons, and on, so let me show you this one. You have 2 carbons, and on the 2 carbon you have 2 chlorines. Here you have 2 carbons, and on 1 carbon only both the chlorines are there. Here also parent chain is having 2 carbon, here also parent chain is having 2 carbons, so the number of carbons in the parent chain is same. So it is not a chain isomerism. This will be what? Position isomerism. Okay, clear? Fine. Now let us go to the next type of isomerism, that is called as metamers. Okay, so metamers means what? Different arrangement of atoms or groups on either side of the functional group. Okay, very simple one. So now you can see this is generally found in ethers, okay, and ketones generally. Okay, now you can see here this functional group is there, oxygen, and this side you have 2 carbon, this side you have 2 carbon, right? So if I draw the structure, it is like this: CH3, CH2, O, CH2, CH3. Okay, now if you draw this one, what we will get? CH3, CH2, CH2, O, CH3, right? So now what we can see, on this side of the carbon we have 2 carbons, and here we have 2 carbons. Here we have 3 carbons, and here we have 1 carbon, right? So when you have different groups attached to the breezing or functional group, then we call it metamers. Okay. Next you have C2H5, CO, C2H5, C3H7, CO, CH3. So if I draw this one, if you see the molecular formula of this one, what it is? We have 4 carbon, right? And I have 10 oxygen and 10 hydrogen and 1 oxygen. Here also you can see you have 4 carbon, H10 is there and 1 oxygen is there. So definitely they have same molecular formula but different arrangement of groups besides the functional group, then we call it as a metamers. Here if I draw this one, C2H5, CO, C2H5, it is like this. Okay, this is there, and this one is having 1 2 3 4 5 carbons. So what is the molecular formula? 5 carbons. Then you have H here is 10, right? H 10 and 1 oxygen. Now here what we will draw the structure, it is like this, C3, right? So CH3, CH2, CH2, then we have C double bond O, CH3, right? So 1 2 3 4 5 is there, then you have 3 4 5 6 7 3 10 is there, and 1 oxygen is there. Okay, fine. Next, coming to the functional isomers. So it means different functional groups will be present, same molecular formula but different functional groups. Okay, now you can see these two examples, CH3 CH2OH, okay, and CH3 CO CH3. If I draw the structure of this one, it is CH3 CH2OH, okay, and this structure if I see CH3O CH3. Now can you see the molecular formula of both of them is what? You have 2 carbons, you have 6 oxygen, 6 hydrogen and 1 oxygen. Here also you have 2 carbons, 6 hydrogen and 1 oxygen, right? So this functional group is called as alcohol, right? And this is an ether functional group. So same molecular formula but different functional groups, then we call it functional isomers. Similarly, you can see acid and esters. Okay, so suppose I draw this one CH3COOH, CH3COOH, okay, and you have one more, okay. So now if I see 2 carbons are there, then we have 4 hydrogen and 2 oxygen, 2 carbon, 4 hydrogen and 2 oxygen. And next, if you have again 2 carbon, 4 hydrogen and 2 oxygen, right? So now you can see these two are equal. Sorry, that means the molecular formula is same, but here which functional group is present? COOH. This is an carboxylic acid group, right? And here if you see, this is an ester group, right? So these are having same molecular formula but different functional groups, so we can call them as functional isomers. Okay, fine. Now let us move towards the stereoisomerism. So stereoisomerism, the first thing, definitely the molecular formula will be same. Now see how I can explain you. See, isomers, okay, how you can easily understand. Isomers means they have same molecular formula. Okay, now again we have discussed isomers is of 2 types, that is your structural, okay, and stereoisomerism, right? So in structural we will have different IUPAC names, okay, but in stereoisomerism you will have same IUPAC name. Okay, that's the first thing that you should know. So what is, they have same constitution and sequence of covalent bonds but differ in relative positions of their atoms or groups in the space, okay, are called as stereoisomers. So they have same bonding, so that is why they will have the same IUPAC name. Okay, now what are the types here? Geometrical and optical, okay, and in geometrical you have types. First we will discuss what are the type of geometrical isomerism and we will calculate the number of geometrical isomerism. Okay, these we will discuss, and as I told you, optical isomerism I will be discussing in the next class. Okay, fine. So first coming to geometrical isomerism under stereoisomerism. What is geometrical isomerism? It arises due to the restricted rotation of CC double bond. Okay, so always remember, whenever geometrical isomers come, okay, it is around the CC double bond. Okay, now also these are also known as diastereomers. So what is diastereomers we will understand in optical isomerism. Can be separated, now different groups on the restricted sites. Now see, this is the condition, on what condition the geometrical isomers can be present. So you can see, suppose I have C double bond C, okay, 1 second, yeah. So now C double bond C, and I have, for example, this side CH3 and I have one H and CH3, right? Now if you see this one, I can write it in 2 forms. If you have C double bond C, I can write H and CH3, and this side H and this side CH3, okay. And another form I can write like this is I can write CH3 here, CH3 here, H here and H here. Okay. Okay, right. So now you see CH3 here and CH3 here is anti to each other, right, opposite to each other. So these type of isomers are called as trans isomers. Okay, you can see in the type we have cis and trans, and you can see here CH3 groups are on the same side, then we call them as cis isomers. But if you know, if you write their IUPAC name, okay, both of their IUPAC name, what you will do, 1, 2, 3, 4. So I'll write but 2ene. Okay, here also 1, 2, 3, 4, 1, 2, 3, 4, but 2ene, right? So their IUPAC name is same. Okay, but they have different arrangement in the form of cis and trans. So what is the condition? This are the, see, this carbon which is having the double bond, okay, these are the carbons where the rotation is restricted, means you cannot rotate this bond like this, okay, you cannot rotate that. So in this restricted rotation sites, the two groups attached should be different, okay, this one and this one should be different, this one and this one should be different. Okay, so if you have a double bond like this, and if you have here A and B, so the condition is A should not be equal to B, and if you have C and D here, then C should not be equal to D. Okay, so cis and trans understood. Cis means the group should be on the same side, the similar groups or the same group should be on one side, and trans means the same group should be on the opposite side. Now we will understand what is E and Z isomers. Okay, so remember, E and Z isomers is based on atomic numbers. Okay, note down this one, it is based on atomic number. We'll do a lot of examples now, it will be cleared. Okay, so sorry, let us see this one. So first one, if you see, we have to tell whether it is cis or trans or E or Z. E and Z we will just discuss now and we'll solve the question. So here you can see CH3 on the same side, H and H on the same side, right? So yes, this will show geometrical isomerism, right? It will show geometrical isomerism. And what type of isomerism it is? It is cis, right? Next one, if you see, this is like this, right? So this side there is hydrogen and this side there is hydrogen. This is methyl group and this is ethyl group. So these are different groups attached, right? One side methyl and one side ethyl. Okay, now in this type of questions, when you do not have the all the groups attached as same, means here you can see to this carbon also it is CH3 and H, to this carbon also it is CH3 and H. But here if I draw the structure, it is like this. This side you have ethyl group and this side you have methyl group. So in these type of conditions or these type of questions, we use E and Z. Okay, so we have to give atomic number here. Now see, to this carbon, I'll draw it like this, CC. Okay, one side I have ethyl group, one side I have H group, and if I see like this, ethyl group and H group are on the same side. Okay, and this is methyl group, right? Now you have to put numbers here. Okay, so how to give number? So let me expand it and write down. 1 second. We have CH2, CH3, and here you have CH3. Okay. Now you see carbon and hydrogen, whose atomic number is more? Here carbon atomic number is more, so definitely this is 1 and this is 2. And this side if you see carbon and hydrogen, carbon atomic number is more, so this is 1 and this is 2. So now 1 and 1 are on the opposite side, 2 and 2 are on the opposite side, right? So then this one will be called as Z. Okay, if you get 1 1 on the same side, 2 2 on the same side, then we will call it as, sorry, this is E. 1 second, I confused you. Eraser. Okay, this is E. Okay, so what I'm saying, if 1 and 1 on the opposite side and Z, like 1 and 1 are on the opposite side, 2 and 2 are on the opposite side, then you will call it as E. If 1 and 1 are on the same side, 2 and 2 are on the same side, then we'll call it as Z. Okay, let us see next example. Okay, here if you see, you have bromine and hydrogen, right? So after bromine, here what is there? Yes, this one will be having more atomic number, so this is 1 and this is 2. Now here how will you identify? See, here what is the structure? The structure is like this. Let me draw it. You have Br, okay, C, double bond C, H, okay, then you have C, one side H, and you have both the bonds to oxygen. And if you see here, it is C, 2 bonds are to hydrogen and 1 bond is to oxygen, right? Now compare here. First, if you move this side, this is attached to carbon, this is also attached to carbon. Next, here also oxygen, here also oxygen, right? But you see here, that is double bond oxygen, means you can think that it is bonded to oxygen 2 times. Like that you can think this carbon is attached to oxygen 2 times, but here it is attached to oxygen only 1 time. So this one will get more priority. This is 1, this is 1, this is 2, and this is 2. Right? Now you see 1 and 1 on the same side, 2 and 2 are on the same side, right? So that means this is your Z configuration. Okay. Coming to next question, if you see here, atomic number is same, right? But here the deuterium mass is more, so this is 1 and this is 2. And here this is 1 and this is 2. Sorry, oxygen 18 is 1. Okay. So mass wise, right? Oxygen 16 is 2. And this is 1, right? So again 2 and 2 are on the same side, 1 and 1 are on the same side, right? Then this will be called as Z isomerism. Next one, if you see here, both the side H is attached. I told you the first condition for geometrical isomerism is the 2 groups attached to the restricted location should be different. But here 2 groups attached to the restricted location are same. So that means this does not show geometrical isomerism. Okay, this will not show geometrical isomerism. Clear? Fine. Now let us do next question. Here if I put this is bromine is 1, hydrogen is 2. Here you see only 1 carbon, here we have 2 carbons. So this side the mass will be more. So this is 1 and this is 2, right? So 1 and 1 are opposite side, 2 and 2 are on the opposite side. So this will be E isomer, right? Next one, if we see, here you have CH2, here you have CH2, then you have bromine here, then you have oxygen here, right? Bromine mass is more, so that definitely this one will be 1 and this one will be 2. Now if you compare here, first carbon, second carbon, here third we have carbon, here we do not have, so this is 1 and this is 2. Again 1 are on opposite side, 2 are on opposite side, so it is E isomer. Okay, clear? Fine. So now this one is important, one rule you should remember here, that if you have same atoms bond are present, okay, then triple bond will be given more preference than double bond, then single bond. Okay. Now if you have 2 atoms like triple bond will be given more, and then single bond, double bond, and then single bond. But now here if you see, the number of bonds are different. Like for example, you are comparing like this. Okay, one side you have C triple bond N, okay, and another side you have C double bond O. Then which one will get more priority? So you see here, first you compare, this is C, this is C. Next oxygen is there, here nitrogen is there, right? Different atoms are present. Oxygen mass is more, so definitely this one will get 1 and this one will get 2. Okay. Next, if you have C double bond N and C double bond C, like this, you have C triple bond N and C double bond C is there. Okay. Here you have H, or let it be like this. Now you see first carbon. Then here we have carbon, here we have nitrogen. Nitrogen mass is more, so definitely this is your first two. This one will be given first priority, this one will be given second number. Now if you see like this, you have C triple bond N, okay, and you have C triple bond C, suppose. Now you see carbon, okay, next is nitrogen, next is carbon. Again nitrogen is having more mass, so this one will be 1 and this one will be 2. Like this you have to give the priority. Okay, we'll do one question now. Again based on E and Z you have to tell simple question. Out of fluorine and chlorine, chlorine is more mass, fluorine is less mass, so 1 and 2. Bromine and iodine, iodine is more, right? Iodine is more, bromine is less, so 1 on the same side, 2 and 2 are on the same side, so it is Z isomer. Here if you see, this is same group is attached on both the carbons, so you can see you have H and CH opposite side, H and CH on opposite sides, so this is trans. This is not E and Z, this is trans, because we have same groups attached on both the restricted locations. Here if you see, again these are 4 different groups, so we will do chlorine will have more mass than oxygen, so 1 and 2. Here what is attached, first carbon is attached, here first iodine is attached, so definitely iodine is having more mass, atomic number of iodine is more. Then do not have to check here, okay, first atom only you need to check. If first atom comes same, then go for the second atom, okay. So again now you see 2 and 2 are opposite side, 1 and 1 and opposite side, so it is E. Here if you see, this one first carbon is attached, here hydrogen is attached, so this is 1 and this is 2, okay. Next here if you see C6H5 and you have C double bond OH. So here what is the structure? If I just try to draw this one, it is like this, okay. I can draw, I think, like this, okay. Yeah, this is the structure, and this side you have, this is the structure, right. So now you see, after you go here, this side carbon, this side carbon, okay. Now next is also here carbon, but next here you have oxygen. So oxygen is having more mass, so definitely this is 1 and this is 2, right. You do not have to see that there are more number of carbons here, no. The first atom carbon, second atom oxygen, second atom carbon. So here only this one wins, so this one will become 1. So 1 1 opposite, 2 2 opposite, so it is E isomer, right. Next question. You have same groups attached on both the side, right, CH3, CH3, H and H, so it is cis isomer, okay, it is not E and Z, okay, fine. Now let us do one thing, how to calculate the number of geometrical isomers, okay. This is not there for KCET level, okay, but you might know because the level of exam might increase, so that is why this is very basic thing that you should be knowing. So now if you see that if the end group is different, means you can see here end group is CH3 and here the end group is Br, right, or it is an unsymmetrical alkene. So unsymmetrical alkene means you see how many numbers of carbon are there, 1 2 3 4 5 6 7 8 9, right. So you can see towards, if you move 1 2 3 4 5, this is the center carbon, I can say. If I move from this side, I am getting CH, I got another 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 CH here, I got here CH2 and Br, right. So from here this part is different, right. So this is unsymmetrical alkene, you cannot divide it into equal halves. So if it is an unsymmetrical alkene, then the number of stereoisomers will, the number of geometrical isomers will be equal to 2 to the power of n, okay. And what is n here? N is equal to number of double bonds, okay. So now if you see in this particular structure, okay, so how many double bonds we have, okay, how many double bonds we have here? So you can check, you have 1 double bond, 2 3 and 4, right. So I can write the number of, okay, geometrical isomers is equal to 2 to the power of 4, right. So 2 to the 4, 4 to the 8, 8 to the 16, okay. Next, if the end group is same, then that means symmetrical. So 1 2 3 4 5 6 7 8, okay. So you can see this is somewhere middle, you see this side if you move and this side you move, you are getting the equal half, right. Both are having same group on the like on both side of this middle part, right. You can cut it into equal halves. Then if that is the case, then the number of geometrical isomers is equal to 2 to the power of n minus 1 plus 2 to the power of p minus 1, okay. Now n, so we know what is the number of double bonds, but what is p here? P is equal to n by 2 if n is even, p is equal to n plus 1 by 2 if n is odd, okay. Now let us do this question and see here. Here how many double bonds are there? 1 2 3. So n is odd here, then what is the p value? 3 plus 1 by 2, that means 2, 3 plus 1 is 4, 4 by 2 is 2, right. So that is 2 here. So now you can substitute p equal to 2, n is equal to 3 and calculate the number of geometrical isomers. So n is equal to 3, okay. P is equal to 3 plus 1 by 2, that is 2. So 2 to the power of n minus 1 plus 2 to the power of p minus 1. So that is 2 to the power of 2 plus 2. So you will get answer 6. So number of geometrical isomers here will be 6, okay. So yes students, that's all. So once again PU 2 Success Blueprint test series is available for you people at a discounted price of 599 rupees, so that you can practice exams, like you can write mock tests and prepare for your PU board and get 95% and above. Okay, so if you are interested in this, so please go to the description section, link is there, click on that and buy the test series as soon as possible. Okay, this will really help you to boost your preparation. Okay, so that's all students in this class. In the next class we will study about optical isomerism, which is very important. Okay, this geometrical isomerism and optical isomerism is not given in detail in the textbook, but yes, I will be discussing that in detail, so please watch the complete series. Okay, so almost like I can say another 4 videos will be coming in this organic chemistry part. Next we'll do even hydrocarbon chapters. We are going to cover organic chemistry in very basic, very detail, all the fundamentals will be covered. So please watch this series, and if you have any doubt, please comment down, I'll definitely address it. Okay, this will be helpful for you even if you are applying for NEET or JEE, then also this content is required. Okay, so thank you students, and see you soon in the next class.